Welcome to Unreal Science, where we explore the hidden frontiers of the cosmos, just 18 light years away, to a newly discovered super Earth that could change how we see our place in the galaxy.
Space is vast and silent, yet sometimes something very close to home suddenly speaks to us. Just 18 light years away, astronomers have found a new super-Earth, orbiting a dim red star called GJ251. They've named it GJ251c, and it might just be one of the most promising worlds we've discovered so far. This new planet is roughly 4 times the mass of Earth, big enough to hold on to a thick atmosphere, small enough to still be rocky, and close enough to make us wonder, could it be another home waiting quietly in the darkness? Discovered using a combination of high-precision radial velocity data and astrometric analysis, GJ251c orbits its small red dwarf star once every few weeks. That star, located in the constellation Canis Minor, is faint but stable, a perfect candidate for hosting life if its planets are positioned just right. And that's what's making astronomers so excited. This super-Earth sits near the edge of its star's habitable zone, the thin shell of space where liquid water could exist on a planet's surface. Now, before we get carried away with dreams of oceans and alien skies, there's a lot we don't know yet. We don't know if this planet has an atmosphere. We don't know its composition. We don't even know if it's truly habitable. But that's exactly why it's fascinating. Let's start with what we do know. Red dwarf stars like GJ251 are the most common type of stars in the galaxy. They live for trillions of years, far longer than our sun, and they often host planets in tight, compact orbits. That means any super-Earth orbiting them is easier to detect and easier to study with next-generation telescopes like the James Webb Space Telescope or the upcoming Extremely Large Telescope in Chile. The team that discovered GJ251c used the CARMENES spectrograph in Spain, designed specifically to find small planets around cool stars. They noticed subtle wobbles in the star's motion, a telltale sign that something was tugging on it. Each tiny wobble, each shift in light, revealed the fingerprint of an unseen world. After weeks of analysis, the pattern was clear. There was a planet roughly 4 Earth masses orbiting every 14 days. Now imagine this, a world slightly larger than Earth, orbiting so close to its red dwarf sun that its yaw lasts just 2 weeks. The sunlight there would be dim and red, like a perpetual sunset. The sky would glow in shades of orange and violet. If the planet's rotation is tidally locked, meaning one side always faces the star, one hemisphere could be locked in eternal daylight, while the other could be locked in eternal darkness, other shivers in permanent night. And somewhere between them, along the twilight belt, might exist a narrow region where temperatures are just right for liquid water. That's the magic of habitable zones around red dwarfs. They're small, but they can exist. And if GJ251c really does have a thick atmosphere, it could distribute heat evenly enough for life to survive, maybe even thrive. Scientists are already planning the next steps. The James Webb Space Telescope may be able to analyze its light spectrum during future observations, searching for gases like oxygen, methane, or carbon dioxide, the chemical fingerprints of biological activity. If those gases are ever detected, it would be a seismic discovery, proof that a world beyond our solar system may breathe. But even without that evidence, GJ251c is important for another reason. It's close. Just 18 light years away means it's practically next door in cosmic terms. For comparison, Proxima Centauri b, the famous nearby exoplanet, is just 4 light years away. So we're talking about the next ring in our neighborhood, reachable by future probes within the next few centuries, if technology continues to advance. Let's talk about the science a bit more. Super-Earths like GJ251c are fascinating because they sit in the missing middle of planetary evolution. They're bigger than Earth but smaller than ice giants like Neptune. We don't have one in our own solar system, which means each discovery of a super-Earth teaches us something new about how planets form. Are they scaled-up rocky worlds, or miniature Neptunes covered in thick atmospheres? We don't know yet, but with each one we find, we're piecing together the puzzle. Interestingly, the discovery of GJ251c adds to a growing trend. Nearby red dwarf systems seem to host multiple small planets, some even Earth-sized. It raises the possibility that our galaxy could be filled with habitable planets orbiting faint red suns, invisible to the naked eye, but shining with potential. On C's surface right now, what would we see? The star would loom enormous in the sky, burning a dull crimson. Shadows would stretch long and soft. The air, if it exists, might be thick with dust or clouds glowing in red twilight. The planet's gravity, stronger than Earth's, would make every step heavier, but the view above would be spectacular. A horizon where day and night never end. Of course, this is imagination, but imagination drives science. Every world we discover reshapes our sense of home. When the first super-Earths were found 20 years ago, they were just dots of data. Now, with instruments like JWST, we can glimpse their skies, sense their chemistry, and even measure their temperatures. In the next few years, GJ251c will likely become one of the priority targets for atmospheric study. Its proximity makes it bright enough to be observed in detail. Astronomers will look for transits, moments when the planet passes in front of its star, to study the starlight filtered through its atmosphere. That light could reveal secrets: water vapor, carbon dioxide, maybe even something we can't explain yet. And that's what keeps the hunt alive. Every time we find a planet like this, we're reminded that our solar system isn't unique, that somewhere, just 18 light-years away, a world not so different from ours might be circling its quiet red sun. We may never walk there, not yet, but for the first time in history, we can see it, measure it, and imagine what it might feel like to stand beneath its alien sky. Because maybe, just maybe, the universe is more like us than we ever dared to believe. And that's why discoveries like GJ251c matter. Not because they tell us where we are, but because they remind us that the story of life might not end on Earth. It might be just beginning to echo across the stars. This video is based on currently available astronomical data and published research from observatories and space agencies. Interpretations are for educational and speculative purposes. Unreal science does not claim that life has been confirmed or that this planet is habitable until verified by peer-reviewed scientific evidence.